All right. Yeah, thank you very much for letting me be here. It is always an honor to talk here at the AWE. Maybe first some short words about myself. I'm in augmented reality now about like almost 20 years now. I started like 2004 at the Fraunhofer Institute for Computer Graphics doing augmented reality research, like applied research. And I published my first scientific paper in 2005 about model target tracking, and we did like lots of applied industrial projects and research, proof of concepts and technical feasibility studies. And like 6 years ago, we took like the most promising technology, like this model target tracking, out of this big pile of technologies and created like a startup. And serving like the model target tracking as a first technical software solution addressing mostly other augmented reality developers. So here, this is like an example video from our first expo at the AWE, where we had like a nice car and where we were demonstrating like the first public version of our model target tracking SDK at the AWE in 2017. And like we have been also like the first, like at that time there wasn't lots of other model target tracking around, so we have been like also one of the first people who have published a solution for like model target tracking which only relies on 3D CAD models, and like these CAD models are the only reference for enabling like the augmented reality experience. We have lots of customers using this technology. There are some leading industry partners, but the most interesting customers are like platform customers who use our SDK as a technical building block and then serve any kind of other applications. So this is like more like a deep tech vertical technology, which is used for like many different use cases. So the big benefit of this technology, that is it's a really light. It's not light sensitive, so it can be used within any lighting conditions. It doesn't have to use any preparation and can be used like anywhere. And the only link between the model target tracking is like the 3D geometry of the 3D data, which makes it very easy and applicable in many industrial use cases. So we serve like this model tracking. We also have like some other tracking techniques like image tracking and marker tracking, but there are so many other tools available, so this is like not that important anymore. We deploy this on any kind of devices, like on iOS, Android devices, also on Windows. But like we also provide like this SDK for the HoloLens or like the Magic Leap, and we look at other glasses which are coming out there and to support them. Most of our customers use like Unity and create their applications within Unity, but it can also be used natively. Then it was kind of hard. Doing like deep tech is always kind of hard because it takes some time. The sales cycles are really long. And to participate more in the value creation chain of the whole technology, we created on top of this tracking engine an end-user application where we don't address like don't address other augmented reality developers, but like end users, quality engineers who want to have like a ready-to-use solution. And this is like our second product, which we call Twin, like in relation to digital twin. So these two kind of software solutions are used in such a way that the SDK is used by other augmented reality platform providers or any agencies who create applications with that technology and then serve this to any end users or customers. And with our quality inspection solution Twin, we just directly serve like the end customers with a ready-to-use solution. Why talk about like pitfalls? Like in that time, also during the applied research at the institute, but also within the startup, we created lots of projects for industrial use cases, lots of proof of concepts, and technical feasibility studies. And we did many things wrong, and we did also lots of things right. And I wanted to share like this information, what worked out well and what didn't work out that well in the whole journey of having like some technology and applying this technology into any industrial use case. So first, important is to really solve like a business need. When we look at the Gartner hype cycle, there was like 10, 12 years ago, we were going through the hype, and there was also lots of venture funding, and everybody was talking about AR. Then we went through all the valley of disillusionment, and now we're somewhere on the point where we get like on this plateau of productivity, which is good. And so we have like also use cases where the technology of augmented reality is more adapted in industrial use cases. At the beginning, everybody was doing augmented reality because it was just fancy and it was just something very innovative, but it didn't solve a business need, which was, of course, not fulfilling then any purpose. One problem we saw that it was very hard when we jump with very high expectations very early and create like an augmented reality solution which is just solving everything at once. For example, like mixing use cases like navigation, wayfinding, guiding some factory worker through the factory, and then guiding him the way to a machine, and then doing some maintenance within the machine, and then doing like opening a web shop and ordering spare parts. And this is just like too much. And then these projects are just not going everywhere because it's just too many things all at once. A way better process was just going step by step and doing the small steps and always focusing on the steps which are the most critical ones. For example, like a web shop is like not very critical, so this is just like some extra work which should not be done like at the first in the first step. So we always have to look at the value. What does the value really bring for the use case? And we have also seen lots of like applications where augmented reality seems to be an interesting use case, but there was no really a value that the augmented, like that the 3D graphics are placed onto the physical machine. And for example, one use case was where we created step-by-step instructions for maintenance, and at the end we did user studies, and the user found out like there's no point in when the first step is just switch on the main switch, that they don't need really to augment this onto the real main switch because this is so easy to see. And we had like a virtual reality fallback, and they could just see the 3D model, and there was no additional value putting the 3D animation really in the context because it was just too obvious. Or like another one was, for example, making lots of animations, and yeah, I'll get to that one later on. So there are different use cases which are more valuable and like less valuable. Wayfinding, pathfinding is of course an interesting use case. It's very tech heavy, but needs lots of preparations. Sales and marketing are like kind of simple use cases. For example, showroom apps which demonstrate like fancy features of a vehicle. Then training or maintenance, they're very content heavy. So the value always lies within the content and like the effort which needs to be done to create this content. Another interesting use case is like the quality inspection. And like we saw in this use case, like a sweet spot, because there's like a high value in the quality inspection use case to detect differences between virtual and physical models. and it's not that content heavy and can be like more easily scaled within the whole production of some industry companies. So here, like some small examples. Here, this is like a marketing use case we created. And so this is, of course, like a fancy app to showcase like features of a vehicle, which is, of course, some effort to create like the whole content. And yeah, it's like an interesting thing, but it doesn't really scale a lot because we have to do this like all over again for like any other type of car. Maintenance and repair is like an evergreen. Here, this, in contrast to the marketing app, which was a final application which was deployed and used. And with marketing and repair, we never got out of this concept phase and created only like proof of concept projects. But definitely also like a valuable use case, but way more content heavy. Here are some examples of the quality inspection use case. So this is our quality engineering app, which we named Twin. And here the user can take the tablet and just overlay the 3D models, identify differences, be mobile, and just do this inspection anywhere on site. The benefit is that there's like not lots of involvement into the data creation because like the data itself, like the 3D data which is needed for checking itself is like the content. So similar as like social media users are producing the content themselves for the platform, for the quality inspection use case, the content is also produced by the users themselves, because that's the purpose of the whole application, to check like the virtual 3D models against the physical parts. Okay, then next, technology. It's always good to understand the possibilities and the boundaries and limitations of the AR technology. So if the expectations are too high, and projects are probably going to fail because the expectations cannot be reached within like a useful project scope. What we had bad experiences in was like mixing too many techniques together within one use case, like similar to this wayfinding use case, and then like doing some model tracking and marker tracking and other stuff, everything all at once, which makes things like very, very complicated. Where we also had problems with is when we want to roll out stuff, that tracking techniques are very useful when they don't need lots of preparation or like pre-processing. So for example, we had like projects where we created like SLAM maps for like some maintenance and repair applications, like similar as like ARKit is doing this now, taking an image sequence, creating like a SLAM map, using this SLAM map, putting it in the coordinate system, and then apply this to the application, doing some step-by-step maintenance instructions. The problem was that this worked well just like on the spot, but this just didn't work at all when you just take the car or the engine, put it to some other place with completely different lighting conditions, and have the expectations that it just works like the same way. So we had very good experiences for like museum applications. When you're in the museum and make like a SLAM map, this works very fine because then everything stays the same, and it's like a very well conditioned environment. But for industrial use cases with lots of lighting and lighting changes, reflecting materials, this is kind of hard because the tracking does not work, and understanding that this is like a limitation of like certain tracking techniques really helps to create like projects or like in industrial applications on the long term. And so in this case, we also switched like more towards the 3D models. Like earlier, everybody was complaining, I don't want to use 3D CAD data because CAD data needs to be available and we don't have this available. Today, this is not a problem because every everything which is produced, there's cat data, and so this is like not a problem anymore. But this was mostly the reason why we used like SLAM maps and used the SLAM maps as a reference. So yeah, it's good to have to understand like the limitations of the technology and keep this in mind, so to like not run into problems when we want to scale like the application to like larger or like a wider use. So yeah, here this is an example of like a SLAM map. Here the IKEA Place app, which just places like an object somewhere in the room. But like with this model tracking approach, we can really put the 3D data in a very specific context and do like a precise alignment of this 3D model. And we can also move the 3D model, and there's no limitations where this model is placed because it's only relying on the geometry. Like there are also achievements for like a more advanced tracking techniques. So here this is an example where we also try to automatically detect different parts. So because I mentioned like it should not be good, it's not good to mix too many tracking techniques all together, but it still, of course, can be interesting mixing different kinds of computer vision algorithms to detect, for example, like here, the existence of certain parts or the correct alignment of certain parts, which of course provide like a big variety of additional use cases for using the computer vision, not only for aligning a certain object, but also for doing advanced tasks and assisting like the end user in whatever he's doing, like for example, for the quality engineering for these checks. The next pitfall was like the content. So many use cases are depend on the content. Like doing a proof of concept is easy. Then you can do like the content manually, and things look nice when you have like a nice looking proof of concept, a demo. But at the end, you have to scale like the 3D data and the content within the whole use cases. So you should not underestimate the content creation efforts when you have like a nice proof of concept running. And of course, when there's like lots of stuff to do and you want to do a rollout of 200 maintenance workflows, this is like a huge, like the majority of the whole work. Emphasizing animations, this was also something which we put lots of effort in, but which didn't bring any value. For example, like creating animations for like maintenance tasks where you have like a screwdriver and the screwdriver is like rotating clockwise to show the worker what to do. We got like feedback that this is just like one managing director told us, like if he wants to use like this kinds of applications, he would just like, if there are any workers who need these applications, they should get fired, because like everybody should know how to use a screwdriver. And making lots of animations pointing out that the screwdriver needs to be rotated clockwise to tie the screw is there's no value in this animation. So there's also no value in making lots of efforts into these kinds of animation and like rich media. And so also like for the whole visualization, it's interesting to keep it simple and to create these kinds of visualizations which are interesting. Yeah, like for these quality inspection use cases, which is like a really graceful use case. There, the benefit is that no authoring needs to be done, and the content is already there, given by the 3D data, which makes the whole application like really easy to scale and to deploy. There are also lots of interesting content solutions out there from Scope AR, 3D, or TeamViewer who have great frameworks to generate this content, and which makes it possible to create like content in a way which doesn't provide too much effort. So having these content management systems really helps also when you have like really content-heavy use cases like maintenance and repair. Next thing, have a strategy to scale from a proof of concept to like a daily usage. It is kind of useful to think about the rollout not when the proof of concept is finished, but like in the very even as soon as as early as possible, because when like all efforts which have to be put into the proof of concept project, there's like always lots of manual work involved, but you have to have like a strategy like how to scale the whole application, like regarding the content, if you do it like in-house or if you want to do it with any supplier, and how to put like the existing application, like the augmented reality application, into existing processes, and how to really create like a workflow from the beginning to the end. And yes, you should keep this in mind, otherwise there might be also problems. So also having people involved, not only like the innovation managers, but always people from the factory floor who are using these applications, and they have been also given us lots of insights, like how to use software, if it's like usable, or if this is like a process which does not work within their given process, how they have been used doing stuff like in early days. So what we do with our twin solution, when we developed this with our reference customers, we created like a proof of concept first, but then we had this always evaluated by people on the factory floor, and they did some tests and also could prove the return on invest by, for example, here like the reduction of faults by 82%, or also the reduction of the inspection time, which really helps to provide like a value and like a return on invest. So we started like with the first team, and then of course there are two dimensions to scale or like to grow and expand the rollout. When like one team is using the system, of course you can apply this to different teams in different locations and other sites. So for example, one use case is like quality inspection, like inspection of incoming goods. It can be used like at different sites, or like also the same team, for example, of quality engineers, they can use an application for the inspection of incoming goods, but then also the inspection of the configuration of fixtures, or other use cases are like the inspection of assembly stages, or like also end-of-line control. So this would be like the extension into new use cases, and of course you can mix these two together and expand like with new use cases and also new teams and other sites. Last thing, yeah, beware of the hype. It's always good to balance between like proven solutions and like cutting edge devices. Well, when there's like a new device out there, we always get asked, hey, can you support like the Apple Vision Pro or like other devices? And we always think this of course, this is interesting. These are like very cool devices, but we have very good experience for people who just use like these tablets, because the tablets are very easy to use, and you can just press some buttons, and it's just everybody knows how to use a tablet. And when we address them with like glasses, this was way more complicated, and many people were just not getting like the HoloLens air clicking and other interaction methods was just so complicated. Nobody wants to use this at the end. So it was, of course, like using standard tablets is not so innovative, but like it's so proven and it just works so much better. And in most cases, we advise like our customers, we know all these classes. We also technically support these classes, but for creating value, it's way better to just take the technology which is there and which is just proven. So yeah, these were like one of the most interesting pitfalls we identified like in the last decade. Like identify valuable use cases which always provide value, understand the limitations of the technology, don't have too much over expectations, always have content strategy in mind as well as like the rollout strategy, and don't always go with the hype which is out there and rely on proven technology. So this is it. Thank you very much for your attention.